I was worried about those little black holes forming in the Large Hadron Collider. Well, there's been obviously a lot of angst about multicore and manycore programming, and I really hope that you're beginning to see, with the kind of experience that Anjay was sharing with you this morning, that those fears, those concerns, I think, are beginning to subside as more and more people take this kind of programming challenge to heart and engage their minds and their energies at programming, because the potential here is so great. And I'm talking about real programmers that are programming multi-core and many-core machines every day, not somebody locked away in some ivory tower, trying to figure it out, but people who are solving real problems. The way the media has portrayed it, and these are just a few of the quotes that we've picked out over the last 5 years since the introduction of the Core Duo processor. And the way it's been portrayed, you'd think you'd have to be some kind of freak to actually program these machines, or as we like to say in the labs, you'd have to be a ninja programmer. Don't worry, I'm not going to bring some guy dressed in a black outfit on stage again. We've already done that once in this IDF. In fact, I think they sent that outfit back to the cleaners, so no ninjas today. But if you look at the people doing multi-core and many-core programming, they look just like you and me. And they don't carry throwing stars of various forms or knives or whatever. They are just the kinds of programmers that tackle challenging problems every day. So our goal at Intel is really to banish ninja programmers forever. Now I hope a ninja doesn't come running out right now. But what I want to do is show you a set of 4 examples, that's 4, not that, 4 examples of real live multi-core and many-core applications. They're all running live here on stage, no magic, no tricks, and nothing's getting piped in from a national lab someplace. Some are running on PCs and some are running on servers, and both are equally appropriate for multi-core and many-core applications. And you'll meet the developers and you'll hear their stories. I'm going to start with web applications, just like the ones we use every day when we launch our browsers and we start to move around the internet. To support web applications, it takes many databases, if you want to think about that way, content repositories of various sorts, in order to build those dynamic web applications. And if that complexity wasn't enough to scare you, you have to do that over millions of concurrent users. So the legacy databases are really in trouble here because they were never designed for these kinds of massive workloads, the kind of traffic volumes that they see, and the complexity and rapidity of the queries. As a result, there's been a substantial amount of innovation that's gone into making those legacy systems perform as if they were built yesterday. And a lot of that work involves multi-core architecture. So come on with me, come back here. Billy's here. Billy, you brought your data center, I see.
I did. Good morning, Justin. We got it rolling on wheels right here.
I know. I don't think Google has anything to worry about.
Not at all.
So, how do people go about solving the problem that I just described?
So after a lot of experimentation, what they finally ended up doing was moving the database into memory. Just move the whole thing into RAM.
So an in-memory database kind of solution.
Yeah, and actually what we're showing here is a use of the open source project Memcache, where they move the entire database into RAM. Now RAM is fast. It's 100 times the bandwidth that we got off of disk and 1/1000th the latency. So the performance boost is huge.
Okay, so if you do that, how does multicore get in the mix? I mean, just putting it all in memory isn't going to give you the horsepower you need.
Well, it helps certainly, but we take advantage of multi-core as we're showing here. And what we can do now is the best reported results to date have been 560,000 transactions per second.
Wow.
But with multi-core, we can go over 800,000 transactions per second and at about a fourth the latency. Huge boost in performance.
With just this much
Just 48 cores.
48 cores in that little rack.
Yep.
Wow, that's really, really impressive. What's the next step here? Where do we go from here?
Well, we continue to optimize the code and work with the open source community to make it go even faster.
Okay, so 1 million queries per second, just around the
It's
corner?
on the horizon.
All right, thanks, Billy.
You bet.
Okay. Sure, give it up for Billy Cox.